Alright, this is the day 2 of 1.6. We're going to work on absolute value inequalities. So what that looks like is to understand how we solve these problems, let's consider the following. The absolute value of x is less than 5. So what are some values that x could be? Let's think about that. If I were to plug in here, what would be less than 5? Well, I could plug in a 4. The absolute value of 4 is less than 5. I could plug in a negative 3, because the absolute value of negative 3 is 3, which is less than 5. I could plug in a 1. Absolute value of 1 is less than 5. So in other words, the inequality says x can be any number that is less than 5 units. So less than 5 units. Graphically, what that would look like if we're at 0 here, then we have up to kind of this value. That would be 5 units, so anything in there. And then going this direction here, that would also be 5 units. So anything from here or here. Now consider x is greater than 5. So what are some numbers that we could plug in there? The absolute value of x greater than 5. We could plug it in 6. We could plug in 8. We could also plug in like a negative 7. So in other words, the inequality says x can be any number that is more than 5 units. So what that would look like graphically, again at 0 here, then more than 5, well here would be those 5 units, but we want more than that. So that would be anything going this direction, so 5 or more. And then looking at it the other direction, then we would be anything going this way. Because this is 5 units, we want more than. So not anything in here, but everything on the left or the right. So notice that greater than is giving us the or. So that's one thing that's going to be important. And we'll see below. But greater than is going to be an or. And then we have less than up here is going to give us the and, where it's connecting in the middle there, kind of that dumbbell look. So here it is, kind of organized in a chart, and we can see that the less than, the absolute value less, is going to be connected. So think of less as coming together in the middle there. And then greater, they're seeking the greater sides. They're going and they are going to the extremes. So the greater than is going to be the or. And then our and. Okay. All right, let's go ahead and look at a couple of examples and we'll see how that's true. So for absolute value greater than, we just set up our two inequalities here. Now remember, absolute value has two answers because we have to kind of represent that left side and that right side. So we set up where x minus 2 is less than or equal to 3, and then we set up x minus 2 is, we flip our sign, greater than or equal to, and then we make it negative. So when we do a positive and we do a negative, just like when we were solving absolute value, but we have to flip our sign when we do that negative number. So now we can solve. X is less than or equal to 5. Over here, add 2, add 2. X is greater than or equal to negative 1. So we are going to go ahead and graph this. So we'll just pick zeros there. Here's negative 1 then, and we would have a solid circle there. 1, 2, 3, 4, 5 is there. So solid circle at 5. And since we're less than, we're going to be and. Remember, and when it's less, the absolute value is less, it comes together and we just get a little bit in between. So the lesser part in the middle there, which you could always double check. X is less than 5, yep, and x is greater than -1, yep. All right, for the next one, this one's going to have a couple of steps before we can set up our absolute value with two inequalities to solve, because we have to get rid of this stuff that's near that. We can't have that there in order to set up our two inequalities. So what that looks like would be 18. Nope, that's an 8. There we go. Divide by 2. So we're just getting that absolute value by itself. Now that it's by itself, we can see that it is a greater than. This is greater than, so they're going to be seeking their opposite sides when its absolute value is greater. We know it's going to be an or and go opposite directions. But let's go ahead and solve. So absolute values set up those two inequalities, one that looks just like the one above, only with no absolute value symbols. And then the other one is going to have a -9. And remember, when we set up that negative, what happens to our sign? Has to go the other direction. Now we solve. So we get 3x is greater than or equal to 15. Divide by 3. So x is greater than or equal to 5. And then over here, solve this one. So 3x is less than or equal to -3. Divide by 3. So x is less than or equal to -1. So on our number line here, let's just set 0 there. So -1 is going to have a solid circle, and then 1, 2, 3, 4, 5. There's 5. And they're going to go opposite directions. Let's check. X is greater than or equal to 5. So greater than 5, but less than -1. Yep, they're seeking opposite directions because that absolute value is greater than. Okay? So greater seeks opposite directions. Less than is going to be just that and, that middle, when they meet in the middle. All right, how do I get this down to just absolute value? Undo the division. We do that with multiplication. That cancels that multiplication out. Now you can set up. So go ahead, and if you want to pause, you can pause and then try and set up those two and then check. And what we would have here, don't forget to switch that sign and then make it a -8. So now we solve. 9x is less than 7. This one's going to give us a fraction. So we have x is less than 7/9, and then -1. 9x is greater than -9. So x is greater than -1. So here's 0. -1's right here, open circle at -1, and then 7/9. 7/9 is not quite 1, so we're going to just get close. And, oops, it doesn't really look like an open circle there, does it? Well, let's fix that, because it should be open. It's hard to do teeny tiny circle. There we go. So if x is, our absolute value is less than, we know it's going to come together, but we can always check x greater than -1, but less than 7/9. And yep, less than 7/9, greater than -1 makes our little dumbbell look. First step on number 4, hopefully you remember to divide by -2 first. Now if you need to pause and try that one on your own, you can do that. So now we can set up our two inequalities. We have -5, greater than -5 there. Uh-oh, what happens when we have absolute value, which is greater than 5? Can our absolute value be greater than -5? Well, yeah, because those are positive numbers. So that's okay when it's greater. But if we had it the other direction, less than -5, that would just only mean negative numbers, and that would not be okay. But since this one shows all those values greater than -5, there are positives that are greater than that negative 5. So that is okay. We can go ahead and set that up with our two inequalities. Flip that sign, change it to be the opposite. So we have x is, oops, and I forgot to switch my sign actually. When we divide by that negative, should be, there we go. Now that's a no-no. So when we divided by that negative, we can't end up solving this one, can we? I make mistakes too. There we go. Nope, absolute value cannot be less than negative 5. There's no numbers. Those are all negatives. So this wouldn't be no solution. So keep that in mind when it comes to that absolute value. All right, last one is going to be a word problem. So always read through, highlight those things that are important. So to prepare for a job interview, she researches the position, discovers that the average starting salary is this right here. That's important. Actual salary is going to differ from the average as much as $24.50. So how we would write that would be our total minus her actual salary. That absolute value is going to be less than or equal to the difference. Okay, so what we would do is we would set up our two, that's an S, and we would have one that's a positive, and then we would have one that's a negative. So flip that sign, and then we would solve. So minus that 38,500. So negative S is less than or equal to negative 36,050. Then divide by that negative 1. So we're going to flip our sign. And there's possible salary. And then over here, solve. And we would wind up with negative S again. Negative 40,950. Divide by negative 1 and flip that sign. So there's kind of our different values. She could be in between those two values. All right, now's the time to note any questions that you have, or hopefully as we were working through other questions, you were noting ones as you went. So be ready to ask those questions tomorrow.